It's an inequality. Anybody? When something doesn't equal something else.
It's a line, isn't it?
Kind of, can be, doesn't have to be. Sort of. How about just something not fair? And then an inequality sometimes in the real world. Okay, math. It's kind of all of those, I guess. So, in order to refresh your memory banks, we're going to go back to
Sixth grade.
what grade?
Sixth.
Might have been 5th or 6th. Okay? When you have a one variable, okay? So like if you have x is less than 3, okay? It's an open circle and you have it on the 3 and then you have the arrow going in the same direction as long as x is on that side in the same direction as your symbol. Remember that?
Yeah.
Okay? And the open circle is because 3 is not included. But you could have 4, or less than 3. So 2's an answer, 1's an answer, negative 249 billion's an answer. All right? Anything less than the 3. Does that ring bells? Coming back? All right. So that means that if x is greater than 2, then we're going the other way. If you have less than or equal to, then you use the closed symbol because now it includes your number. Right?
Are you just making these numbers up?
Yeah. I'm just making them up. I was just picking 3 too. Yeah. And if it's just x is equal to 2, then you have just your dot. Okay? Who's your math teacher in 6th grade? Sam Flippo?
Yeah.
Stelzer? All right. You remember her talking about all this stuff with you? I think. Okay. So, if you are doing an inequality with 2 variables, now we're jumping to 8th or 9th grade, maybe? I don't know. And it's equal, then you go to your slope intercept up to, I need my ruler. There's just your line, right? You agree with that? And only the points on that line are your solution. You can have more than one solution, but it's just the points that are on the line. Right? All right. Then, if we have, say, y is less than 2, if it's less than, just like how less than is an open circle, you use a dashed line. All right? So if y, so the way I do it is I start with y is equal to 2. So that means that there's going to be my line. Do we agree with that? Yes? Okay. If it's less than, then you shade below. Right? If you're not sure, pick any point Okay? So let's say I'm going to pick 0, 0. And substitute it into the equation. Is 0 less than 2? Yes, so that means that solution should be in the shaded region. Does that ring bells? Yes, no, kind of? Okay. All right, let's do another one. So y is equal to 2x. So there's my y-intercept. I go up 2 and over 1. I'm going to have a dashed line because it doesn't include it. It's just greater than. Okay, so this was less than. Oops. Okay. Good. Now, if it's greater than, since it's greater, that you're going to shade above. Okay? But I can't remember that, so I'm going to pick a point. Give me an easy point. How about 1, 1? Well, is that easy enough? Okay. Let's put it into the equation. Is 1 greater than 2?
No.
Okay. So that's false. So it's not in the solution, or not in the shaded area. So since 1, 1's right there, that means I am shading above. Does that make sense? Too much blue. We need to pick colors. All right. Less than or greater than is going to be another shade below. But this time you're using a solid line. There's x is 2. There's my solid line that's not quite as straight as I'd like it. Okay. All right. I don't understand what shade below me says on this one because I got this vertical line. So let's pick a point. What point should I pick? How about 0, 0? All right, so if I use 0, 0, is 0 less than or equal to 2? Yes. So it's in the shaded area. And so that means that's going to be the less than. Good? All right. All right, so let's solve for y. So I have y is greater than or equal to negative 2x plus 6. If it's greater than, I'm shading which way? Above or below? Above with greater than. So here's 6 down to over 1. It's less or greater than or equal to, so I have a solid line. And if I shade above, okay, I want to double check myself. So I'm going to pick the point 0, 0. And when I put it into the equation, 0 is greater than 0 plus 6. False, it's not in the area. All right, good refresher on that? Yes? Good, because when we have system of equations, we're going to look for the solution set. Solution set is those that applies to both of them. Okay? So, if I graph the two equations, I'm going to have y is less than or equal to negative x plus 2. And it's going to be a solid line. Oh, sorry. My bad. Thank you. And so I'm going to shade below. Would you agree with that part? And when I graph the other one, I have a negative, or I mean positive 4, but I have a negative 2 down 2 over 1, down 2 over 1. Okay, and it's greater than or equal to. So which part of the graph is included in both solution sets? That's in the solution set, and this is in the solution set. So it ends up that just this little sliver of the graph is our actual solution. Does that make sense? Yes? What time is it?
So is the
Run out
top
of
one,
time.
is
Huh?
the top one part of it?
No, just the highlighted area is going to be it. All right. We'll finish these up tomorrow then. All righty.